Hi everyone, it's me again, your virtual teacher. And today our topic is about speed. What is speed? In simple terms, speed is the distance traveled by a moving body in unit time. The relationship between speed, distance, and time are connected by the following relation. Speed is equal to distance divided by time. Time is equal to distance divided by speed. And distance is equal to speed times time. Examples are a car travels 65 kilometers in 1 hour. We say that the speed of the car is 65 kilometers per hour. Maria runs 360 meters in 180 seconds. We say that the speed of Maria is 360 divided by 180, which is equal to 2 meters per second. If a plane travels 1,500 kilometers in 1.5 hours, we say that the speed of the airplane is 1,000 kilometers per hour. We will solve some examples about speed. Sample problem number one. Two athletes are running from the same place at the speed of 21 kilometers per hour and 18 kilometers per hour. Find the distance between them after 10 minutes if they move in the same direction. Solution. From the previous slide, distance is equal to speed times time. To solve the distance between them, we will subtract the distance of athlete 1 from distance traveled by athlete 2, which is equal to speed of athlete 1 minus speed of athlete 2 times time, since time is the same for these two, which is equal to 21 kilometers per hour minus 18 kilometers per hour times 10 minutes times 1 hour over 60 minutes. We need to convert minutes to 1 hour to hour because the unit is in hour. So solving this equation, it will be equal to 0.5 kilometers or 500 meters. Therefore, the distance between them, the two athletes, after 10 minutes is 500 meters. Sample problem number two. Two athletes are running from the same place at the speed of 21 kilometers and 18 kilometers per hour. Find the distance between them after 10 minutes if they move in the opposite direction. Remember the first problem is they're going in the same direction. Now they're going in opposite direction. So this is our solution. From the previous slide again, the distance is equal to speed times time. So same as problem number one, we will find the distance of athlete 1 minus the distance of athlete 2. Therefore, it is equal to speed of athlete 1 plus speed of athlete 2. Notice that I add the speed of athlete 1 and athlete 2 because they are going in the opposite direction, and it will be multiplied by time. So it will be equal to 21 kilometers per hour plus 18 kilometers per hour times 10 minutes times 1 hour over 60 minutes, converting again to hour since our unit is in hour. This will be equal to 6.5 kilometers. Therefore, after 10 minutes, the two athletes will move, or the distance between them is 6.5 kilometers. Sample number 3. A train 100 meters long is running at a speed of 55 kilometers per hour. What time will it take to cross a 150 meters long tunnel? So see our illustration below. Our solution from the second slide, time is equal to distance divided by speed. So the distance, it will be the length of the tunnel plus the train length divided by speed. So it will be equal to 150 meters plus 100 meters, because see, it will cross They need to cross the tunnel, so therefore the whole length of the train should pass through the tunnel. So we will add also the train length. So 150 meters plus 100 meters divided by 55 kilometers per hour is the speed of the train. So we will convert it to meters per second. That's why we multiply it with 1 hour over 3,600 seconds times 1,000 meters over 1 kilometer. So it will become 250 meters divided by 275 over 18 meters per second, which is equal to 16.36 seconds. Therefore, it will take 16.36 seconds for the train to cross the 150 meters long tunnel. Sample problem number 4. A train 100 meters long is running at the speed of 60 kilometers per hour. In what time will it pass a man who is running at the speed of 6 kilometers per hour in the same direction in which the train is moving? Our solution, since we are looking for the time, so it will be equal to distance divided by speed. And then this will be equal to the length of train divided by the speed of train relative to man, since the object is moving, the man is also moving in the same direction. So we will compute first the speed of train relative to man, which is simply the speed of train, which is 60 kilometers per hour, minus 6 kilometers per hour, the speed of the man. So it will be equal to 54 kilometers per hour, or in meter per second, it is equal to 15 meters per second. So we can now solve the time for the train to cross the man, which is equal to 100 meters is the train length divided by 15 meters per second, the speed of train relative to man, and this will be equal to 6.67 seconds. Therefore, it will take around 6.67 seconds for the train to pass the man who is running at the speed of 6 kilometers per hour. Sample problem number 5. A train 100 meters long is running at the speed of 60 kilometers. In what time will it pass a man who is running at the speed of 6 kilometers per hour in the opposite direction in which the train is moving? So it's almost the same as sample problem number 4, but in this time, the man is running in the opposite direction of the train. So solution, same equation, time is equal to distance divided by speed, which is equal to the length of train divided by speed of train relative to man. But this time, the speed of train relative to man is equal to 60 kilometers plus the 6 kilometers per hour speed of man, since the man is going to the opposite direction of the train. So it will be equal to 66 kilometers per hour, or in meters per second, it is 18.33 meters per second. So, solving for the time for the train to cross the man, it will be equal to 100 meters divided by the speed of train relative to man, which is equal to 18.33 meters per second. And this will be equal to 5.45 seconds. Therefore, it will take 5.45 seconds for the train to pass the man who is running at the speed of 6 kilometers per hour. That's it for today, guys. We will solve more problems regarding with this topic, speed, in the next episodes. See you next time.